Basic post block structure. A traditional post block has two components. The first is a post block label, or the post block name, and one or more post lines. The post block label declares the traditional post block. A post block label must start in the first column, may contain letters, lowercase a through z or capital A through z, and numbers 0 through 9, and the underscore character. So those are the only characters that are allowed. It truly is alphanumeric with the inclusion of the underscore. So A through Z, 0 through 9, underscore, and post blocks are generally case sensitive. So if you spell it with, one character capitalized, you're always going to have to capitalize that one character. For this reason, let me go and grab our sample post here. Where did I stick this? That's right. Okay. So it was in here. So here's this sample post we created. And if we open it up, you're going to see that all of, in general, post blocks are lowercase. So when we start getting down here and you start looking at the names of these post blocks, you're going to see that in general, standard practice is to always use lowercase characters. In fact, the only thing where they recommend you use uppercase is when you use enumerators. And we'll get to that when we start talking about variables. Enumerators are essentially simple values that usually don't change. So normally a variable is built with multiple slots where you can stick data, and an enumerator is basically built with a single slot to stick data in, so it uses less processing power. Okay. The post block label must be on a line by itself, except for a comment, which starts with the pound sign. Typically begins with the letter P. The exceptions are post blocks that begin with L or M. You notice that's a lowercase l. These are used for lathe posts that are intended to support mill turn applications. In these posts, the post blocks that begin with M are used for mill operations, and post blocks that begin with L for lathe operations. There's a little note here. It says MP-based posts that are used by Mastercam lathe for mill turn applications are completely separate from the MP.NET based posts that are used by Mastercam's mill turn product, which is true. So my lathe class that I teach for Mastercam lathe posts covers the generic Fanuc 4X lathe post. It's the MT lathe post. So it does mill turn, but it's only 4-axis mill turn. So it's not the MP.NET stuff. Note that predefined post block labels also end with a $ character. For example, PSOF. It's also important that you don't use the $ character on any user-defined post blocks. So only the post blocks that are already recognized by MPDLL would use the $ character. All lines of MP code that follow the declaration are considered part of the post block until a label in the first column is encountered. The presence of any label in the first column marks the end of the post block. This label can be another post label or post block label, a variable label, or post function declaration. This does not apply to post comments, any line that begins with a pound character. These are ignored and will not end the post block. It says, note, do not create post block labels that begin with P underscore underscore. Okay, it's important to note. Here's an example of some traditional post blocks. P tool change. Here we've got PTLCHG $. P block, user defined post block declaration. A comment is allowed. So you notice that this line that follows P block is a comment line. P comment 2, user defined post block declaration with Boolean logic if else branching. And here we have some post lines. SCOMM equals UCase SCOMM. So there's a function being called, uppercase, to convert the comment into all uppercase characters. And here is an if-else block for outputting G code for 1007 or everything else. Post block types. There are many post block types. Each serves a purpose in the posting process. Listed here are the main types and subtypes. There are user-defined post blocks and predefined post blocks. Hold on one sec, guys. Okay. Of the predefined post blocks, there are several categories that they fit into. Pre-process post blocks, preparatory post blocks, pre-output post blocks, standard post blocks, command post blocks, and post-process post blocks. And we'll talk about what those are as we talk about MP processing. User-defined post blocks are declared by the post writer. User-defined post blocks can be called or jumped to only from another post block and can never be called as entry post blocks based on the NCIG code or from an internal post-executable routine. So in order for a user-defined post block to work, you must call it from within an entry post block. It has to kick off the process from somewhere. Predefined post blocks are an integral part of the MP language. The names of predefined post blocks are part of the MP language. Predefined post blocks can be called by specific NCIG code as entry post blocks, command statements, or post-processing order. You can easily recognize a predefined post block because its name ends with $. Even though a post block is predefined, you can freely edit or modify its implementation in your post. Also, even though the names of all predefined post blocks are present in MP, that doesn't mean they are all implemented in every post. For example, ppost is a predefined post block that is used to modify the NC file after it is written. However, it is not implemented in the generic Fanuc 3x mil post, so it will not be executed when that post is used. You need to declare it yourself and add post lines depending on exactly what you wish to do. Since it is predefined, however, MP knows when to call it. Pre-process post blocks. So here's an example with ppost of a post block that is optional. It doesn't exist by default in most posts because most posts are just designed to generate NC code output and that's it. but you may wish to do some processing to the NC code even after it's closed. So what are some things we can do? We can open up the closed NC code and scan it for information, for example. Sometimes we will put a warning in ppost that will test the number of characters that were written to the NC file and display a warning if the file is too long to fit in your machine. So there's all kinds of things we can do. The question is, what do you want to do with the post? That's always the question. What kind of output do you need, and how do we go about getting it? How do we generate it? And there's usually a way, believe it or not. MP has been around and been being developed and enhanced for a long time. So there's a lot of mechanisms, and there are more that come out all the time. So for example, we have this new tool table logic that allows us to do a lot of things that aren't related to building a tool table. It actually gives us a mechanism to look forward and backwards through the NC file, or excuse me, through the NCI file, which is something we couldn't do before. So the MP language is always being enhanced. There's always new stuff that's being added to it, and that's part of what makes it powerful. Pre-processed post blocks. Pre-processed post blocks are called before the NCI file is read. These post blocks do not have access to the NCI file data. The following are pre-processed post blocks. pprep, $, allows post instructions after the post is parsed, but before the NC and NCI file are opened. Do not attempt to output to the NC file in this post block, because the NC output file is not yet opened. PQ allows post instructions after the NC and NCI file are open, but before reading the NCI data. So see MP processing on page 93 to learn more about these post blocks. So this goes through and it lists all the different post block types. Preparatory post blocks, pre-output post blocks, standard post blocks, command post blocks, post process, talking about p-post. And I would encourage you to read through this section that talks about post blocks and post lines. We're going to start to skip ahead a little bit, and we're going to go on to the variables. And so some of the stuff we're going to end up coming back to. Because this is talking about post lines and types of post lines. And we'll come back to this when we start talking about logic. Let's see here. Oh, yes, this is what I want. There we go. Okay, let's see where we're at here. A little bit longer to go. So, as I mentioned, we're going to jump ahead just a little bit, start talking about variables and strings. I think it'll help make the post block section make more sense. Variables are used to store, access, and manipulate data. MP supports both string and numeric variables. This chapter includes the following sections: Numeric variables on page 58 describes the types, how to declare and initialize them. It also describes functions that let you look up values from tables. String variables on 67 describes how to declare and initialize strings and functions for working with strings. It also describes how to use string selector functions to look up strings based on a numeric value. And outputting variables on page 74 describes how to format numeric variables for output. It also discusses modality and the use of variable modifiers in output statements to control when values are written to your NC program. On page 123, formulas, vectors, and arrays will teach you how to use variable declarations to create more sophisticated structures, such as vectors, arrays, and matrices. It also discusses assignment and Boolean formulas in more detail and outlines the other mathematical and logical functions that are available to the post writer. See the variable and post block reference in the MP documentation for a complete listing of all predefined variables and strings. The other way that we can access the predefined variables and strings is to start typing the string name, or just A or B or C or D, any of the characters of the alphabet into the code expert editor. And you're going to get a list of all of the predefined data that starts with that character. So if you're going to get a P, if you type P, you're going to get not only variables, but you're also going to get a ton of post blocks as well. Numeric variables. Numeric variables are used to store floating point decimal numbers, integers, and Boolean true-false values. Each numeric variable is identified by a unique label. Some variables are predefined variables. You do not need to declare these variables before using them. And remember that a declaration, when we say declare a variable, we're talking about creating it and initializing it. And that's different from formatting. Okay, so some variables are predefined. You do not need to declare the variable before you use it. And the names of all those predefined variables end with a $sign character. Other variables are user-defined variables. These are created and declared by the post writer. Numeric variables can be used for values passed from the NCI file, values calculated in MP for a specific routine, switches that enable or disable posting options, and user-defined variables defined by the post writer. MP also includes command variables. When used on a line by themselves, they trigger a specific routine in MP. So whenever you see a variable by itself on a line, it's going to tell MP to do something. We can see an example of that. So if we go to PSOF, which is the start of file, eventually it's going to call ptoolchange.com, the common tool change, because this is the MP master base post. And we will see we have comment $sign on a line all by itself. Whenever we see the comment $sign command variable on a line by itself, that tells MP to dump all of the comments that are stored in the comment buffer and process them one at a time. So all of the comments that have been saved and stored up till that point are going to be output. And we're going to do some exercises next Saturday for modifying how that takes place. So when comment $ is seen all by itself alone on a line, we actually end up calling p comment 2. And p comment 2 is the post block where we process all of the different comment strings. So based on what the value of the NCI G code is, this tells us what type of comment is being processed. And you can see here that we actually have comments that tell us. So 1005 is a manual entry as comment. 1006 is a manual entry as code. And we have different lines to process the output depending on what type it is. So as a comment, you can see down here, we have this scom str is the open parenthesis string. This scom _n is closed parenthesis. So we're wrapping the comment with open and closed parenthesis to designate it as a comment. Down here for type 1006, we just output scom on a line by itself. So 1006 is as code. In other words, we're directly outputting the manual entry as G code to our file. Or 1005 will output it as comments. 1007 is comment with output line change at point. 1026 is as code with output line change at point. So these are from the change at point command. Type 1008 is the operation comment. And what we're going to be doing is modifying this section of code. If G code equals 1008, and we're going to modify that in order to delay the output of the operation comment. Because what ends up happening is everybody wants to use their manual entry at the start of the file as the header. So they want to be able to create a manual entry where they can enter comments and they can enter maybe some startup codes, G10 lines. There's so much stuff you can just enter as a manual entry. And then, but they also want their operation comment to be output in the right spot. So we'll do that. We're going to create some logic to do that this coming Saturday. We're just over the halfway point of the course, or excuse me, of the class, not of the course. And I want to try and stay on time, I guess, as much as we can. So this video is just a little bit shorter than the other video. That's okay. In order to kind of stay on time, we're going to take our mid-class break. I'm going to split the video. If you guys have questions, as always, go ahead and type them into the chat box. If you want to ask it in person, let me know, and I can, turn on your microphone. You can ask it in person as well, and we'll go from there. So I'll go ahead and split the video, and we'll get started in about 10 minutes after our break. So I'll see you guys, like I said, in about 10 minutes from now. Thanks, guys.